All right, this is Honors Geometry, section 3.3, slopes of lines. If you recall from Algebra 1, the slope of a line is rise over run. And the way we calculate that is y2 minus y1 divided by x2 minus x1. Most of the lines are going to be diagonal lines. This line has a positive slope. This red line would have a negative slope because it's going down from left to right. Occasionally, we get into some of the special cases. If we have a horizontal line like this green one thing I know is that all of the y values are the same going from left to right, and the slope of this line would be equal to 0. If we have a vertical line like this red one, all of the points have the same x value top to bottom, and the slope of this line we would say is undefined. It has no slope. It would be some number divided by 0, which we can't subtract, so the slope is undefined. If two lines are parallel to each other, like this blue line and this red line, then we would say that their slopes are equal. And the other special case we have is if you have two lines that are perpendicular to each other, like this red line and this blue line. If they're perpendicular to each other, that means they intersect at a right angle, which would then be 90 degrees. And in this context, if two lines are perpendicular to each other, their slopes are opposite reciprocals. For example, 3/5 and -5/3, 1/2 and -2. First example. Given these 4 points, are lines A, B, and C, D parallel to each other, perpendicular to each other, or neither? And it doesn't say that I have to graph this, but sometimes a graph makes it easier for me to figure out. So AB, 6, 1, 2, 0. So here's A, here's B. Line AB is going to look something kind of like that. And I'm going to calculate the slope of segment AB. To do that, it's a good habit to do your second point minus your first point, so BA. So I'm going to do 0 minus 1 in the numerator, divided by 2 minus 6 in the denominator. That's going to be -1 over -4, which would simplify to 1/4. So that is the slope of AB. And if I look at it up 1/4, even with my really quick sketch of that one, that does seem pretty accurate. Then for CD, point C is at -1, 4. Point D is at 7, 6. So here is line CD. Calculate the slope of CD. So D values minus C on the top, y minus y, that's 6 minus 4 divided by 7 minus -1. 2/8, that also simplifies to 1/4. Now, in comparing those two slopes, we can see that they are the same, which means that these two lines are parallel. This next kind of problem is definitely the hardest one we're going to see early on in this chapter 3. We have two lines that are perpendicular to each other, and we're supposed to find the value of K to make it so they're perpendicular to each other. And what makes it so difficult is this variable of K makes the problem much more abstract than it otherwise would be. It's harder to graph this one also. I can try. Point A is at 3, 7. That's not so bad. Point B is at K, 1, and I have no idea what K is equal to. Is K positive? Is K negative? I don't really know. So I'm just going to say, let's put point K right, or point B right here. Coordinates are K, 1, and so here is line AB. And then point C is at K, 8. Again, that's kind of hard to understand. I'll come back to that in a second. Point D is at -2, 9. So if point D is right there, point C is at K, 8. And I have to be perpendicular. So here's my attempt to try to draw this one. Point C is at K, 8. Point D is at -2, 9. And I can already see a problem with my drawing. This y value for point A is at 7, and it's above the y value of 8 right there. So it's not a perfect graph, but it gives me something to look at. These are perpendicular, so I can put a right angle in there. And now I need to get to actually start solving for k. And that perpendicular is all about the slopes. So slope of AB is equal to 1 minus 7 divided by k minus 3. So it's negative 6 over k minus 3. That is the slope of segment AB. Slope of segment CD is equal to 9 minus 8 divided by negative 2 minus k. That comes out to 1 over negative 2 minus k. Now this is perpendicular. Perpendicular is harder than parallel because if these were parallel, I would just set those two expressions equal to each other. They're not parallel, they are perpendicular, which means they're opposite reciprocals of each other. It's like if one was 3/5 and the other one was negative 5/3, I couldn't set them equal to each other. But one thing I know about opposite reciprocals is that if you multiply them, the result is always negative 1, right? 3 times negative 5, 5 times 3 is negative 15 over 15 is negative 1. So if I take these two expressions, negative 6 over k minus 3 times 1 over negative 2 minus k, it should come out equal to negative 1. Now this is, again, bringing those together, we're making it so that they're perpendicular to each other. This equation can be kind of hard to solve. If I multiply the numerators and multiply the denominators, it's equal to negative 1. It looks like this. That still looks pretty difficult. Blue was separate fractions. We multiplied the numerators, multiplied the denominators. It looks like this. And I don't particularly like that even still. So I'm going to actually have to multiply some things out here, specifically that denominator. K times negative 2. So I'll get negative 6 up there. K times negative 2. K times negative k. Negative 3 times negative 2, and negative 3 times negative k. And again, this is all still equal to negative 1. And this problem is looking absolutely brutal to me because of the fractions. So to make it easier on myself, I'm going to take the left side and the right side and multiply them both by the same thing so that there's no longer a denominator. Specifically, if we multiply the left side by what this denominator is, it leaves us with only a negative 6. I multiply the other side by that, negative 1 is going to multiply all by all those and give us this. Again, if I had something like 3 over x plus 2 equals 1, and I multiplied both sides by x plus 2, that would get rid of this denominator, and then we'd have 3 is equal to 1 times x plus 2, and we'd have an equation we could actually solve. So this black example of here is much simpler because it's just linear, whereas this one we do have a quadratic. It is a quadratic. I've got to use my good Algebra 1 skills. Specifically, on the right side, we have a k squared leading it off. 2k plus negative 3k is negative k. And then we want the left side to be 0, so add 6 to the left, add 6 to the right. There's nothing else after that. So then as I look at this, I want to factor it. GCF, k times k minus 1. So k equals 0 and k equals 1 once I've solved it. So if k equals 0, that'll make it so that we have perpendicular. If k equals 1, that would make it so it's perpendicular. Hard problem. One more in this example, and I would encourage you to pause it and see if you can get this started. I could draw it again. I don't think the drawing helped me a whole lot, so I'm just going to go straight for the slopes. The slope of AB is k minus 2 over 5 minus 3. That's k minus 2 over 2. The slope of CD is equal to k minus negative 1 over 3 minus 8. So that's k plus 1 over negative 5. Now these two are, again, they're perpendicular, so they're not equal to each other. Sometimes we will see some parallel examples, and then we would just set them equal to each other. Instead, I can multiply them to negative 1 again. So k minus 2 over 2 times k plus 1 over negative 5 is equal to negative 1. Multiply out those numerators. So your first, outside, inside, last, you're multiplying that entire numerator. K squared minus 2k plus k minus 2. Multiply your denominators. That's negative 10 is equal to negative 1. The nicer thing this time is to get rid of the fraction and multiply by this denominator of negative 10. I think that's a little bit easier. If I multiply the left side by negative 10, it gives us just the numerator, k squared. Combine those to get negative k minus 2. Multiply the right side also by negative 10, we get this. Subtract 10 from both sides. And then factor. This time there is no GCF. There's nothing that goes into all three of them, but you've got to think number pairs. What are the two numbers that multiply to negative 12 and add to negative 1? It would be k minus 4, k plus 3. So then our answers are k equals positive 4 and negative 3. If k is equal to either one of those numbers, that would make AB perpendicular to CD.